Hey everyone, welcome back to another episode of how to get the best out of Claude Code. Now there is an old saying in software engineering, and that is, if a test is not written, the feature does not exist. Now this is a bit of an exaggeration, but it's actually a practice in something called test-driven development. When you're building any piece of software, you should always be writing the tests before you write the code for implementing it. And I know in this age of AI coding, it's very tempting to kind of just one-shot everything. However, if you actually really do this in practice, you know that this is not the way to go about doing it. Take a look at this document written by Anthropic. It says that you should always ask Claude to write tests based on the expected input and output pairs. Then you tell Claude to run the test to confirm they fail first. And then you ask Claude to write the code that passes the test. And you do this for every single functionality that you're building within your application. In today's tutorial, we'll be putting this theory into practice. We'll be building this entire color mixer application that you see over here. It is a great demonstration of the benefits of using test-driven development. And the reason why is that it's very visual. There are plenty of things for the user to interact with, like these sliders over here, all of these different buttons that you see below here, and we'll be building all of this from a single PRD file, which outlines all the requirements that we want for this application. We'll be using several of the latest new features from Claude Code. These include a specialized team of subagents, custom commands for the design and implementation phase, and one of the latest things from Claude Code, which are output styles. Today's video is sponsored by Browserbase, the team behind both the Browserbase platform as well as the Stagehand framework, which we'll be using for our testing today. Stagehand is a framework built on top of the Playwright framework, but you'll be able to move from writing tests that look something like this and instead write tests using natural language and text prompts. As you will see, it actually makes your application a lot more robust, and it also provides a lot more flexibility around the interactions that you can do. Not only that, I will be showing you how you can actually run these tests in the cloud using Browserbase, which provides you with entire functionality such as session replays of the entire test session, a history of all the actions that were taken, as well as useful debugging tools that will make your test development experience a lot better. We'll be using the Browserbase MCP server in order to access this functionality. And you will be able to see why both Stagehand as well as the Browserbase platform makes a huge difference in how you go about doing test-driven development using Claude Code. So are you ready to get started? Let's get going. So what I've done is that I've actually created several subagents. The first set of subagents are the UI designer, the shadcn-expert, and the stagehand-expert. And now these three are going to be responsible for the design phase of this application. So what it's going to do is that it's going to take in a single product requirements document that you see over here for today's app, which outlines the main functionality that we're going to be showcasing. And what we're going to do is that we're going to have an orchestrator that you see over here that will coordinate between the three subagents to ensure that it gives us the output that we want, following which we will actually go into an implementation phase whereby we would then actually use this React TypeScript specialist to go ahead and implement the application based on the outputs that we have. Because we are going to go down a test-driven development route, we are actually going to also use the stagehand-expert over here, not just for designing the test, but also for writing the actual tests that we'll be using during the implementation phase. And that's the whole point of today's tutorial, is to demonstrate to you how you can actually use a test-driven development approach to implementing your application. And the way that we're going to enforce it today with Claude Code is that I've created this custom pragmatic test-driven developer output style. In this way, it's going to ensure that for any functionality that it writes, first of all, it's going to go through a red phase where it's going to write the test and ensure that it fails. It has to fail because the functionality has not been implemented yet. Then it moves to a green phase where it implements what it thinks is the amount of functionality for it to fulfill the test. Then it's going to verify that the test passed. And optionally, we'll have this verify phase where the user gets to confirm that this is working. Now, if you want to learn a little more about subagents or custom commands or output styles, these are fairly new features that have been coming up with Claude Code. I've done several other videos on these topics, so definitely check them out. All right, so let's get going here. So I'm going to do dev, design app, and then I'm going to do docs, and then this PRD file, okay? And what you will see right here is that this custom slash command is going to be the one that's responsible for ensuring that the PRD is ran, and then all of the subagents are coordinated with the orchestrator to produce the required outputs that each of them will have. So let me just draw this out. So it says here, analyze the PRD, and then now it's going to use a multi-agent design workflow for this color mixer application. The first phase is where it kicks off the orchestrator. As I already mentioned, the orchestrator is responsible for ensuring that all of the subagents are actually working at the right time. So whether it's in sequence or in parallel, and then it's coordinating between all of the outputs to make sure that they all land in the right place. Okay, so you can see the very first thing that this orchestrator is going to do is that it started to create the output folder structure based on what it's understood the PRDs to be. So you can see here, for the design phase, we have a single project, which is the simple color mixer, and it's actually time-stamped so that we actually identify that this is the run that is associated with this design phase. And you actually can see this is the most important file over here. It's called the manifest file. And the manifest file is going to be the thing that actually ties everything together. It's going to show you how the requirements tie into all the designs that are going to be output. So you can see that the functionality from the PRD is reflected here. And then the other thing that it's do is show the sub-agents are going to be executed. So you can see the UI designer is go, and you can actually see it right here. It's actually just kicked off right now because phase 1 is now complete. And then you can see after the UI designer is done, it's actually going to run the shadcn-expert and the testing-expert in parallel. And the reason for that is that once you actually have the design, both of these can work in parallel. They don't need to wait for each other in order to complete their task. And this is the power of the multi-agent architecture within Claude Code. You need to understand when it's best to run them in parallel and when you can actually sequence them. And then finally, at the end of it, the orchestrator will then ensure that everything is in place before preparing the final implementation checklist. So let's jump back into our Claude Code screen over here. You can see the UI designer sub-agent is really hard at work at producing things. You can see within agents, you can see the UI designer, and it actually started to mock up some wireframes of how this app is going to be like. So there's going to be a color preview at the top, some RGB controls in between, and then below it's going to have some color presets. It's also going to wireframe the tablet layouts and the mobile layouts as well, so that these are responsive designs. So let's hop back into Claude Code. You can see here the shadcn-expert has been kicked off, and the Playwright stagehand-expert has also been kicked off just as well. And they both are going to be working in parallel, and so this should speed things up. Each of them will maximize the context that's given to them, so to about roughly 200k tokens, give or take some things for the system and agent prompts. The whole idea is that then you will be able to focus them on their task without contaminating them with everything that happened previously, such as what the orchestrator is doing, as well as what the UI designer is doing. It just focuses on what the UI designer has outputted, and they are both now able to work in parallel. Okay, and things have progressed on. You can actually see that the two sub-agents have now produced several of their outputs. So we'll take a look at the shadcn-expert very quickly. He actually has laid out the various different components from the shadcn library that he wants to make use of. It provides a rationale as well as other benefits that go along with it. It has a composition plan of how to put things together, and the other design considerations that will go into using these components. And the next one we look at is actually the stagehand-expert's output. As you can see over here, it's actually a task plan that covers all of the different things that you will need to do to set things up. But most importantly, it has laid out both Playwright tests, but not only that, it has also shown you how to write things using stagehand as well, which, as we go along with this tutorial today, provides a much more flexible and powerful way of defining some of your tests. Now, before we go into all of that, I'm just going to pull this down over here. As you can see, Expert has finished its test specifications. We just need to wait for the shadcn-expert to finish up its last few bits of output before the orchestrator will synthesize and validate that everything is done. And just as I said it, we can see that the shadcn-expert and the Playwright expert are both done now. So finally, the orchestrator is going to come back in and make sure that all of the outputs are in the right order, and then synthesize the final set of things for the manifest file ready for implementation. All right, and you can see over here, the orchestrator has now come up, and it's just going to look through all of these agent outputs that have come up from the design phase, and then it's going to synthesize and validate that everything is there before producing a final update to the manifest file and the implementation plan. Okay, so you can see that the entire process of the design phase has completed now, and it's finished everything that we've laid out. So it's done the initialization of the project, created wireframes, the shadcn components, the Playwright, and most importantly, the stagehand test, and then it's synthesized everything with the visual manifest. So if you actually take a look over here, you can actually see the output of every single thing that has completed during this design phase. As you remember, the manifest file that's sitting over here will actually ensure that we know where all of the different files are. So when you use the implementation plan over here, together with the manifest, this will allow you to make use of all the knowledge and the planning and the research that were done by these specialized sub-agents that you see over here. I'm not going into details into each and every one of these items, but the main thing to understand is that this has provided a very robust framework for you to go ahead and then perform an implementation of your application based on all of this. And this is one of the patterns that has emerged that combines the recommendations to always do a planning phase, but also how you can make use of sub-agents and custom commands to actually tie them together with an orchestrator to synthesize everything in this manner. All right, so now that this is done, we are going to be able to implement this application, combining all of the outputs that we see over here. And the way that we're going to do it is that we're going to be using this second custom command that I've created over here called implement MVP. Now, the main thing to recognize about this implement MVP is that it understands that it needs to look for the implementation plan and the manifest that has come up from the design phase. All right. The other thing to recognize is that it will make sure that it follows a modern test-driven development workflow. So this means it has to go through the 3-phase process that we mentioned earlier. It has to do a red phase where it writes a test based on the requirements, and then it's going to make sure that the tests fail, following which it will go through the green phase where it will implement the functionality in order to make the test pass. It will rerun the test to make sure that the test pass, and then it will do this for each and every feature that's required. So you can see that it repeats this process. First, it's done it for the baseline app that will make sure that it loads, and then it will do it for the UI, and following on, it will make sure that it'll do it for every single component that exists within the app. And the way that I'm going to enforce this is once again using the Pragmatic test-driven developer style, which I can switch to over here. So I'll just select output style, and then I'm going to press this. And what I'm going to do is I'm going to use this version called no verifications, meaning that I'm just going to let this run without any user input until the end. And you can see in this no verify method, I actually just remove the human verification step. But then when you're developing, I will highly encourage you to actually include this verify step, especially when you're building new features on an existing code base. And we will be using this other version where there's going to be this human verification step where you get a chance to actually make sure everything's working right, where we implement an additional feature using the TDD methodology on top of the completed poll. And just to make sure I'm in the no verification mode, and then I'm going to implement MVP. And as you can see, it actually takes in a design folder output path and an MVP folder. So the design folder output path, which is laid out over here, is the one where the manifest and implementation plans lives. So I'm just going to tag this, and I can see bits simple color mixer, and then bits / and I will pick the one with the timestamp, so it's that exact version. Okay. Now the other thing we need is actually the location where we want to build this app. What you can see over here is that I've actually already initialized a boilerplate Next.js app. And the way that I did it is I just did npx create next app at latest, and then I call it my app. And then I'm just going to say yes. I use HatchScript, yes lint, tailwind yes, source directory, app browser, turbo pack. No need to customize the alias, and I'm just going to let this finish up and complete. Now it's going to go ahead and initialize this very simple boilerplate Next.js app. And you can see it's running over here. So I'm just going to go to my app, and I'm going to do npm run dev. And we just give this a moment to kick off. All right. And this is loaded up. And as you can see over here, it is just a boilerplate Next.js app. And this will be the starting point in which we will build our app on top of. Now, this is entirely optional. If you had specified just a plain directory, it will actually go ahead and initialize the Next.js app in there as well. But I just want to save a little bit of time because sometimes the installation of the dependencies can take a while. The other thing that I am going to do is I'm just going to add the 2 dev dependencies, which is the stagehand from Browserbase as well as the Playwright libraries. So what I'm going to do is that do an npm install as well, just to make sure that it's going to pull in the Playwright and stagehand dependencies as well. And once this is done, as you can see, everything is loaded up here. I'm going to do this, and then I'm also going to mention to it that I am running the web server on localhost 3000 npm run dev, so do not run it yourself. It will be continuously accessible. And another thing that I'm going to add is that make use of sub-agents, TypeScript agent for implementation, and the Playwright stagehand-expert for test writing. All right, and so this is going to go off, and you can see that it's going to implement this using the TDD methodology that we've laid out. And then it's going to go based on the design specification. Okay, so you can see the first thing it's going to do is that actually it's going to look into the implementation plan, and then it's going to look at the existing product structure. And you can see it actually sees the Next.js boilerplate, and you can see that Playwright and stagehand install. And then it's going to go ahead and write the baseline Playwright test. Okay, so I'm just going to leave this to run. and continue and build the entire application, and then we will come back and take stock from there. All right, you can see this has now completed. It has gone through the entire test-driven development cycle for all the features that are required. You can see that it continuously swapped between the stagehand-expert as well as the TypeScript specialist as it went through this test writing implementation kind of cycle. And then towards the end, it managed to build the entire simple color mixer app. All right, so I think now is a great time to actually check out how the app looks. All right, so what we're going to do here, first of all, is kick off the server. So I'm going to go into my app and run npm run dev. And this is the state that you can see the project at the end of the development cycle. All the functionality is there. I can switch the red slider, the green slider, and the blue slider. There are a couple of color presets at the bottom as well, so I can switch it straight to black, green, white. And if I wanted to copy any of the hex values or the RGB values, what I would do is then click on these buttons. And as you can see, they are working as expected. So this gives me the hexadecimal value, and this gives me the RGB value. So this application is working to the specs, and I wanted to show you the kind of tests that can be written and why they will be useful in order for you to enable this test-driven development workflow with your application. So let us open up the tests that have been written. See here that we have the regular Playwright tests, and this is what I'm going to cover first and foremost so that we understand why these are useful. But then after that, I'll be showing you a couple of stagehand tests that build upon these and hopefully show you why it's actually a lot more useful to rely on these. Okay, so you can see here for the Playwright test, the first thing that it does is written within a very baseline specification. The main thing that it does here is that it does an app load and then it displays the title. And then it will check that it has the H1 tag in the screen, checks the title is color mixer. It will check for the subtitle description, and it has to say mix and match colors with the RGB sliders. And you can see this is exactly what we see on our screen over here. And the reason why you have this is kind of like a smoke test. It's replaced the Next.js boilerplate, and then it's gone ahead and implemented the baseline kind of like tags and headings that you would expect this page to have. And we have a couple more tests over here. So you can see, it says that the color preview element exists. So it goes around and looks for something called the color previewed. And if we go to our page, you can see that we have a card element that has been labeled as data test ID color preview. So we would expect these tests to all pass. And let me just show you how you will go about doing it. --UI, so you can see a nice user interface. Then I'm going to pass in the test, that subdirectory. This will bring up a nice user interface for you to run all of your tests. So let's look at all of the baseline tests. We have a couple of very rudimentary things that I already covered, such as the app loading. I'm going to be able to run every single test. So the nice and really cool thing that you have just seen is that it has spawned several browsers, and then it's being able to independently run tests against those browsers to verify that everything is working correctly. And this is the power of Playwright and the power of using browser-based testing. You're not just writing unit tests, you're doing some form of integration test with an actual browser. So let's take a look at what has happened here. The nice thing about this UI is that you can actually scrub through the application. So you can see it's just loaded it up here. So I'm going to show you here, everything is all interlinked. So if I click on here and I click on source, you can actually see the actual lines of code based on the test that is happening. So if I go to the first line, it says expect there to be a H1 visible, and you can see on the right, it's actually shown you the exact element that is found. Then it actually says it needs to contain the text color mixer, and it does contain color mixer, so it passes, and then it goes down and searches for a paragraph that says mix and match colors with RGB sliders. And this is exactly what you see here. Don't forget, we actually went through a test-driven development cycle in order to get to this stage. So you wrote the test first and made sure that it failed, which it definitely did, because when you had your Next.js application, it didn't have any of these elements. Then the minimum amount of functionality in order to make the test pass, which is actually getting these elements in, and then finally it runs the test again. This test-driven development methodology is a powerful way of reducing errors, reducing the chances of new features breaking older features. And because of the power of AI, it can actually run really quickly now, because you can get your AI agent to write a whole bunch of these tests, run all of them, and keep them always up to date. And so there's really no excuse for anybody to not be writing any form of tests as part of their development cycle. All right, so now you've seen the power of this, but I wanted to highlight a problem with using Playwright as is. So if you actually look at something like this test that you have over here, which basically just checks that all three RGB sliders do exist. And you see, it's actually fairly simple, right? It just goes over here, it looks for this section over here, and then it checks all of these different sliders in sequence. Now, the problem that you see here is that it's relying on the fact that you know that these sliders are named data test ID slider R, slider G, and slider B. It's also assuming that you know that the labels are called label red, label green, and label blue. The problem with this is that it's actually created a tight dependency and a tight coupling between the test that's been written and the implementation. While this works quite well, it's actually kind of cheating a little bit because it knows the implementation details. And the word to describe for this is very brittle. So let me just show you why. So if I go overhead into here, and if somebody change this to match the convention used above and just change this to RGB, right? And you can see if I run this test again now, I would expect this test to fail. So you can see it's run, it's checking for the elements, and very soon you will see it has failed, right? Because it's not been able to find this label R. This is exactly the problem, because if you look at the application, everything else is actually working correctly. It's just that because we changed the implementation, it's just causing the test to fail. And while it's very useful to catch these kind of things to ensure uniformity in implementation, it's not a very good test because it's actually relied on knowing the underlying implementation detail. So this is where Stagehand comes in. Stagehand is a product created by Browserbase, who are kindly sponsoring today's video. And the reason why Stagehand is extremely powerful is because you no longer have to rely on understanding the implementation detail. Instead, you will be able to use natural language and AI to describe some of these tests. Let me showcase to you how this works over here. All right, so what I've done is actually ported several of these Playwright tests into Stagehand tests. First of all, to show you how writing it in Playwright can be more robust, and also showing you where Stagehand can actually perform certain tests that are a lot more complex and yet easier to understand and verify. So this is the one that we had before, where we actually just made sure that the RGB sliders exist. But remember, it broke because we actually just renamed the implementation. Now I've created a new test that I have over here, and it's basically just going to see if the sliders exist on the page. I'm using the stagehand observe method, which looks at the elements on the screen. You can see all I have to do is say find all three RGB color sliders, enumerate through the sliders, and ensure that I see red, green, and blue. So this is the same UI that's running, but these are all the stagehand related tests. If I go down to this one that we have just done, discover all RGB sliders using observe, I'm going to run this test. Remember previously the one with the replayer failed because the implementation changed. But let's see what happens over here. Aha, no problem at all, because this time it doesn't rely on anything about the implementation detail. Instead, it just loads up the page, uses natural language to see what's on the page, and then finally it determines that everything looks right. Okay, so this is actually really robust, because while the Playwright test continues to fail because of the implementation change, the other test is actually going to pass because it doesn't really matter. And I'm not saying one is definitively better over the other. I'm trying to demonstrate to you where you actually need to think about functional requirements and how you're testing against them versus implementation level requirements. Now you can think about the power of observe. It's almost like giving your AI the power to actually see things now, as opposed to parsing the code that's on the screen. But sometimes it's still very useful for you to be able to extract out things that are going on within your application. And it's very aptly named extract. Let me show you how we can build on what we've just seen with the RGB sliders using extract, right? So here's an example of how you can use extract function. Now I'm going to describe the RGB color slider. I want you to be able to give me lucid information about what's going on. I want to know whether they're visible, their labels, and their current values as well. This is where it's very useful to pass in a schema where you can say, this is how I want you to output your information back to me, the user. And you can see here, I've actually specified for the description of the slider with the following format. And then I'm going to run this test to showcase this test to you. All right, so now I'm going to use this one where I'm going to say exists using AI discovery and extract. And then you can see it's very similar now, but it's going to look at a page and not only observe for the existence of these sliders, but it's actually going to ensure that the values are correct. Let me show you what happens if I change the default value of green over here. Let's imagine this was defaulted to 255 and I press play. It's actually, you will see why extract is so useful. As the test runs, you can see it expected the substring to say value 255, but instead it gave back the value label green, visible true, and value 87. This shows the power of the extract function because you can determine how you want the AI to output the results back to you so that you can actually verify and manipulate it a lot better. All right, so now we've looked at how you can observe and we've looked at how you can extract. The third thing we're going to look at is how you can actually perform actions on your page. At the end of the day, the applications that we have over here are interactive applications. They're very visual, and they're very interactive. This is where being able to perform actions is a useful thing about using stagehand. Very simple. You actually use natural language that you have over here. All right, so if you look at this task that we have over here, I'm going to actually perform the action of pressing some of these preset buttons. So it's going to click on the red button and then use the extract to get the values from those buttons. And then it's going to look at the color result and see whether those values match. So that it's going to check that the functionality of the preset buttons are working correctly. So let's run this right now. I'm going to click on this preset buttons, apply correct colors. And you can see here, what it's going to do is that it's going to click on the red one first. Okay, and so the red one is working. And then after that, you've seen, now it's switched over to click on the blue one. And then it should extract off the values and verify whether or not this is working correctly. And now let's click on white. And then finally, it says that the test passed. This shows you how you can perform actions as part of your stagehand task, which is a very powerful way of utilizing stagehand because now you can perform actions and interactivity while using extract and observe to assess whether things are working correctly. So now you not only can extract, but you now can also perform actions. And this is a demonstration of why stagehand is so powerful because you did not need to know much of the implementation details and could use natural language to perform all of these things. It makes the test more readable, understandable, and it allows you to make it a lot more robust. All right, so now I've covered the 3 key stagehand functionalities that you can make use of, which is observe, extract, and act. I've also told you the reason of why writing tests is actually very useful in order for you to verify functionality and should be part of your development process. In fact, that's how I got this app from a single PRD file designed and then implemented all the way to what you see here with some minor tweaks. So now let's put it all together and I'm going to show you how you would go through a single iteration loop in order to build a new functionality for this app. I just brainstormed a little bit with Claude about some ideas you could use over here. And I think what I'll do is something simple yet that will involve everything we've seen so far. So let's add in a new random color generator. And so what I'm going to do now is switch folder first to make sure that my output style is in this Pragmatic test-driven developer mode. And as a quick refresher, this output style will effectively work in 3 cycles. We will first go into red where it writes the test. Then after that, we will make sure that the test fails. We will implement the functionality that's required. Then it makes sure that the test passes. And then finally, it will double check with me that everything looks correct. Confirm. That is the Pragmatic test-driven developer. Let's begin implementing the random color generator button. Use the subagents to perform the implementation. Use my TypeScript specialist and test writing, which is my Browserbase Stagehand-expert. If you're interested to get hold of these subagent definitions, you can access them in the link in the description below. Finally, I will say do not run npm run dev as I have it running actually, and it's on localhost 3000. So what I'm hoping this will do is that it will actually make use of the test-driven development methodology, make use of the specialized subagents that we have, and then finally get us to the functionality that we want. I'm hoping that this will demonstrate to you the value of actually building functionality in this way, as opposed to simply writing the functionality, looking at it, and then being disappointed when it doesn't quite work the way you expect it to be. It may seem quite heavy-handed when you first try to do it this way, but remember, this is exactly how the Anthropic team develops new functionality and is part of their best practices as well. And now with the power of AI and subagents, you should be able to overcome all of the downsides of having to go through this process very quickly because you can get AI to write all these things for you, as you can see on the screen over here. So there's very little reason for you to not be making use of such methodologies and testing frameworks as part of your development cycle. All right, as you can see here, it's finished writing the stagehand test. And what it's going to do as part of this red phase is that it's going to run the test to make sure that it fails. Okay. And as you can see here, all right, it's going to very likely fail because, well, there's no button that exists. And you can see here, it actually even says it itself. So I'm just looking at the implementation here. This will because the button doesn't exist yet. This is during the red phase of the TDD. And it's confirming it over here, because it cannot even find a single thing called a random button, right? The idea here is to be pragmatic, right? You can work on the level that every time the test fails, you build a minimum functionality in order to make that test pass. Or you can actually say, at least you know the tests are failing. I'm going to build more functionality around it and then run the test again. It's a fine balance because you can actually end up writing so many tests and then iterating very slowly, or you can actually end up like moving too quickly that you don't really know which tests have actually failed because you've gone ahead and built a lot of the implementation without thinking about the test. So it's all about finding a good balance when you're working in this manner. So you can see here, it's moved on to the green phase now, where it's going to use the TypeScript specialist to write the functionality for the random button. So you can see there is a random color button at the bottom, and it's now going to try to verify it by running the green phase. Now it's going to run the green phase, and I can see that it did manage to click the random button because it did randomly change to a new color over here. And now it's clicked the random button again. Okay. And one more time. And it has passed this time. And each time it's verified. You can look at the test over here. It's all in natural language, which makes it very easy to understand. Okay. You can see down here, it actually used extract to capture the initial color, observe to find the random color button, click the button several times, and use extract again to make sure the color changed. And now the feature is complete and it's asking you to test it out yourself. So let's do it ourselves. I'm going to refresh the page, but you can see the random color does exist over here. I'm going to click it and click it and click it and click it. And it's definitely working. This has demonstrated how to use the TDD methodology together with subagents in order to build functionality in a robust way. Now we've covered how you're going to be able to do this as part of your development workflow. One thing to really emphasize about the power of Browserbase is that you don't have to rely on your local machine to perform these tests. One of the best things about Browserbase is that it allows you to run all of this on infrastructure in the cloud, and it can run it much quicker and in multiple instances as well. It actually gives you some really good analytics tools to actually see how your sessions are running. I'm going to be using the official Browserbase MCP server, which allows me to use Claude Code and interact with Browserbase directly on my code project. I've actually deployed this application using Vercel based on everything that I have so far. As you can see, the functionality is here, and the most recent one is the random color that we added, but everything else looks as expected. Now, I'm going to be using Browserbase to perform some of these actions just to demonstrate how the platform is very useful for you to be able to run these automated tests and interactions, and I'll show you why it's so powerful right now. So I'm going to be using the Browserbase MCP. It's just this in my config file with the API keys, project IDs, and you can use Gemini, you can use OpenAI. It supports many different providers as well. Honestly, I've been really impressed about how useful and powerful the Browserbase platform is, because as you can see over here, this is one run that I had testing on the page itself. And it's actually very useful because it has this really nice view that shows you all the actions that have been taken. And you can actually jump into each of them to see what the input was and why it might have failed. It also shows you a lot of information regarding the tokens that went into processing this request. So let's actually do a live demonstration right now. Okay, so I'm just going to double check that my Browserbase MCP server is running, and let's just pull up the test that I have over here. Run the test that we have here via the Browserbase MCP tools. The URL of the application is this. Now I'm going to ask it to run that test and replicate it on Browserbase itself, which uses its own cloud infrastructure to run this test. It's use of the MCP tooling, so you don't really need to know too much about the API. You can actually just rely on natural language to instruct it to do that. Okay, and this is the live view of the cloud browser by Browserbase that's running. And you can see this browser that we have over here is actually a virtual browser that Browserbase has spun up for the purpose of your test. And now it says that the button exists. And you can see replicating the test that we had just now, but this time it's actually running on its browser, on its infrastructure. This is extremely useful because if you're going to have to spin up multiple browsers on your machine, you're going to be limited by your own resources. But this is running in the cloud, and you can make use of the full infrastructure stack to run all of your tests. And once the session is completed, you can see an entire history of all the actions that have been performed, both in video form, but also in a sequence of actions over here. So you can see it went over to the page, then it got the current values before using the random generator, and then it found it using the observe, followed by clicking the random button once and then clicking the random button a second time. And you can actually see the output of each of these fronts. And the best thing is that you can actually share this with your team members if you wanted them to have access to not only the screen recording, but the actual actions and the outputs as well. So that's the power of the Browserbase platform. Combining all of these things together, this is just a really powerful suite of tools that makes your testing infrastructure a lot better. All right, folks, that brings us to the end of today's tutorial. I hope you've seen the value of using test-driven development whenever you're building stuff using Claude Code. With the power of Stagehand, you now have the ability to give your AI eyes to see what you're building, as well as observe extract, and perform actions, which you can then use as part of your task. And you can do all of this with the power of natural language. Furthermore, you're no longer just confined to what's on your own machine and can leverage the power of the cloud to run these tests and have all these additional tools and functionality. So once again, I'd like to thank Browserbase who have kindly sponsored today's video. Head on over to the link in the description below to get hold of Stagehand, the MCP server, and everything else from Browserbase. If you like today's video, give it a like, hit that subscribe button, and don't forget to turn on that notification bell as well, so you'll always be the first to know whenever content like this drops. Oh yeah, you might have noticed that in Claude Code, I have this custom status line, which shows me a lot of information regarding my Claude Code sessions, including which model I'm using, the context remaining, as well as my burn rate in dollars and in tokens. So if you want to know how you can get hold of this or build your very own, you definitely want to check out this full step-by-step video tutorial that I made over here. Alright, till next time, I'll be seeing you.